So in this small session, we are going to discuss about cylinder, cone and sphere. Before that, let's look at what we did with a cuboid. If there was a cuboid and the length, the breadth and heights of the cuboids were L, B and H. You know that suppose if this length is L, if this length is B and this height is H. What is the volume of the cuboid? We wrote volume of the cuboid is equal to length breadth into height. What is this length into breadth? This is the length, this is the breadth. The base area on which this cuboid is kept as an area L into B, right? It's a rectangle. The base of the cuboid is rectangle. The area of the rectangle is L into B. So this L into B basically stands for area of the base. So volume can be written as area multiplied by height. Suppose if you look at a cube, it is also the same case. Suppose you have a cube and the cube has all the sides A and A. So you know all the sides are this is A and this is A. Then the volume of the cube again we will be writing it as A cube, which is nothing but A square into A. A square is the base area. If this is A and this is A, you know that this is base area, which is A squared into A. So volume of a cube also, it is area multiplied by the height of the cube is A. That is why it is area into A, which we call it as height of the cube. So let me write it as height of the cube. So from this we have come to understand that for a regular shape, if it has a definite base area and it is uniform, then you can write its volume as area multiplied by height. Let us consider the case what we have. You have a cylinder. A cylinder has circular basis and circular top. It is nothing but a kind of can, and this cylinder has a uniform base and the uniform top. So this is a cylinder. Now this base is in the form of a circle. If you view the cylinder from the top of the cylinder will be like this. It's circular. And if the radius of this is r, what is the circumference? If this radius is r, this is what that radius I am talking about. This radius is r. Then the area of the circle, we have already learned that it is pi r square. Suppose the height of the cylinder is h. If the height is h, then the base and the top are uniformly from base to top it is the same. So the base area is pi r square. So this is pi r square and this is h. Going from the above notion, volume is the product of base area into height. So the volume of a cone, volume of a cylinder is base area into height, which is nothing but pi r square into height of the cone we consider to be h. So it is pi r square h. Then what about the total surface area? There is a circular surface area at the bottom, which is pi r square. There is a top surface area, which is pi r square. Then what about the curved surface? Let us imagine this thing here. Suppose you have a rectangle. In this rectangle, you have the side is having a length which is equal to h, and you are trying to curl this. When you curl this paper, this rectangular paper, you will get something like that of this cone. You'll get something like that of this cone. Then you know that this is h, and suppose its length is total is L. This length total is L. The area of the rectangle is area equal to L into h. When you curl this, it becomes like this. So the total length of the circle is 2 pi r. We know that the total length of the circle is 2 pi r. Suppose when you cut here, cut the paper here and open it up, you will again get back this rectangular shape. Then if its radius is r, the total length of this is 2 pi r. Then when you cut the paper and open it, this length becomes 2 pi r. This height is actually h. So the area is equal to length into breadth. Length is 2 pi r into height is h. 2 pi r h. So if you take a cylinder, like this, so let's have a somewhat good cylinder that I would like to draw. So let's take a cylinder, and what are the important properties of the cylinder? If its radius is r and the height is h. The radius of the cylinder is r and the height is h. So volume of the cylinder, as we said, pi r square h, and area, the total surface area. There is a top area which is circular, so by pi r square. There is a bottom area, that is pi r square, and this curved surface area, this we have just derived the 2 pi r h. So the total surface area is pi r square plus pi r square, top cap, bottom cap, and the curved surface area 2 pi r h. So this is what the total surface area of the cylinder, which is 2 pi r square plus 2 pi r h. If you take 2 pi r common, 2 pi r into r plus h is the total surface area of the cylinder. If you look at only the curved surface area, the curved surface area is only this surface, lateral surface, then that is equal to 2 pi r into h. I'm going to add 2-3 more things very quickly. Suppose you have this cylinder, and I would like to draw that cylinder again. Suppose you have this cylinder, and what you do is you are trying to form a cone out of this. That means you are cutting out the other things. You are removing this. So from this cylinder, you are making only a cone out of it. The height of the cone is h, as in the cylinder. The base area is still circular, its radius is r. Then this cone will be, if its volume is v, its volume is only 1/3 of the volume. We know that volume of the cylinder is pi r square h. Then volume of a cone will be equal to 1/3 of pi r square h. Volume of the cone is 1/3 of pi r square h. So the important things about a cone are these things. So this time I'll use reasonable straightness. This is what the cone, this is what the base area of the cone. So this one you have to remember it. This one we later in future years will be solving this. This vertical height is different from slanting height. If the vertical height of the cone is h, this radius is L, this is the radius R, this vertical height we call h. Then this one we call slant height of the cone. The slant height is actually forming a right angle triangle with h and r. If this is in a right angle triangle, this is h and this is r, this is going to be equal to root over h square plus r square. So for a cone, volume is 1/3 of the volume of the cylinder, which is 1/3 pi r square h, and this thing you have to remember, total surface area. One is the surface area and the base area. The total surface area is pi r square, which is the base area. You know that very well. This area, it's in the form of a circle, so it is pi r square. And the slant area, the curved area, is pi r L, where L stands for root over h square plus r square. So the total surface area of a cone is pi r square plus pi r L, and the volume of the cone is 1 by 3 pi r square h. The other thing, this slant height, this slant height can be calculated using the vertical line drawn from this top. This top is what is called vertex. From the vertex to the center of the base, the center of the circular base is what called the vertical height. So the slant height is the square root of square of the vertical height plus radius square of the base radius. So the volume of a cone is 1/3 of the volume of the cylinder, which is 1 by 3 pi r square h. The total surface area is the base area, which is pi r square, plus curved area, which is pi rl. So later on, children, when you come to 11th standard, so when I come to you directly, by then I will tell you how this is. Even the proof of it is not required in your 9th standard. We will prove it a bit later. So which is pi r l. So the slant height is root over h square plus r square. Now that we have got a cylinder and a cone. What are things that we need to know about cylinder and cone? The things that we need to, this is pi r square h is the volume. So volume of this cylinder is pi r square h. Cone is 1/3 of pi r square h. Total surface area is 2 pi r into r plus h. Here the total surface area, this is volume. Total surface area here is pi r square plus pi r l. So which can be written as pi r into r plus l, pi r into r plus l. 2 pi r into r plus h, pi r into r plus l, where l is the slant height. So the surface area, the curved surface area here is 2 pi rh, which is the curved surface area. Here also curved surface area is pi rl, where l is the slant height. So remember, these are the things that we'll be using to solve problems on cones and cylinders. So the other thing which I would like to add here itself is a sphere, a three-dimensional shape. It's a ball. So if the ball has a radius r, it's a ball whose radius is r, then this is a sphere. So volume of a sphere is equal to 4 by 3 pi r cube. So in the next session we will see how it is, because we need to basically use other mathematical things which we will be learning later in our next years. So let us try to understand this. If you have a full sphere, which is nothing but a ball whose volume is 4 by 3 pi r cube, if you cut the sphere into half, what you get is only half of a sphere. Let me try to draw reasonably well. So this has a base circular area and there is a cap. This is called hemisphere. So hemisphere will have half of this volume. So volume of a hemisphere equal to 2 by 3 pi r cube. Volume of a sphere is 4 by 3 pi r cube. Volume of a hemisphere is 2 by 3 pi r cube. Its total surface area, since there is no other area, base area, top area, nothing like that, the total surface area of a sphere is 4 pi r square, whereas this total surface, there is one curved surface, one full surface is 4 pi r square, half of that surface is 2 pi r square. There is this base area which is pi r square, because it is circular in shape, which is pi r square. So the total surface area of a hemisphere is 2 pi r square plus pi r square, which is nothing but 3 pi r square. So this is 4 pi r square, this is 3 pi r square.